Alright, good afternoon. It's FY here. Okay, today we're gonna learn the topic of the integrations of rational function. Okay, when we're talking about rational function, um, we will say you will have numerator and you will have denominator. Okay. And when you are come across integrations of rational function, you will come across three types. Okay, the type number one, that is when we have the numerator, the degree of the numerator is always less than the degree of the denominator. What I'm talking here is we're talking about the polynomial. The polynomial, we will have the polynomial in the numerator and we will have the polynomial in the denominator. For instance, we have example like this. Okay, so you have a constant and you have polynomial here, and what you have is you have the degree at here, which is constant, is always less than here, where the denominator, the power of denominator is the highest power we have is x power 2. So obviously, whatever at the top is less than the bottom. Okay, or you have another example. Okay, you have the numerator, the highest degree that you will have is x power 1. And at the denominator, we have x power of 2. Obviously, the degree at the top is less than the degree at the bottom. Okay, when you have that case, okay, so you will come across either the q. We have to check the q. Either the q or the denominator, okay, cannot be factorized, or the q can be factorized. But in this video, we just cover on the q cannot be factorized. Alright, okay. When we look at the example on the q, the type number one, that is when q cannot be factorized. Okay, we need the formula from the yellow table, which I have gave you in the class. Okay, we will need the formula from page number 1, that is your A7, and the formula from page number 2. Page number 2, that is your C1. Let's see, we need that two formula. Okay, there's a second type that we will going to learn, that is when the q can be factorized. Okay, there will be another lesson. Okay, and the third type you will come across when you have the degree of the denominator is higher than the numerator. There will be another lesson. So total you will come across three types. Okay, let's look at the type number one first, when you have the case of the numerator that is less than the numerator and the q itself cannot be factorized. Okay, let me write out the formula of page 1, A7 first, because later we're going to use it. So we need the formula of A7. It will be the integrations of f prime over the f dx, that is equal to ln fx plus c. Okay, the formula for the page number 2, C1. Okay, that is the integrations of 1 over x squared plus a squared dx squared dx is equal to 1 over a tangent inverse or arctangent x over a plus c. So basically we need these two formula in order to answer the questions that is in the example. Okay, let's just look at the example directly, okay? Okay, let me take out the example A. Okay, let's look at example A first. Alright, so we have this. Alright, okay, let's just put other things aside. Alright, so what we have here is, I need this formula. Alright. Alright. Okay, let's just look at this one. Okay, so in order to solve this type of problem, okay, so you will see either you are having a pattern which is you have a polynomial at the bottom, okay, and this one is a constant. You have a constant at the top. You have a constant at the top. Okay, the first thing that you have to think of is, okay, try to manipulate whatever at the bottom, in the form of this, okay, which is you have the x squared. You have the x squared v, okay, and plus with a certain number, okay. So okay, let me rewrite whatever at the top. And in here, what you can think of, if I want to modify this into the form of C1, so I need to factor out 16 from this equation. So if I factor out 16 from this equation, whatever remain here will be x squared plus 9 over 60. Alright, okay, of course 2 over 16 that you can simplify. Once you simplify 2 over 16, that will give you 1 over 8, and write the 1 over 8, okay, outside the integrations symbol, right? Okay, so we will have something like this. Okay, that this is 1 over 8 is coming from 2 over 16. Okay, once you have this, okay, the next thing is try to focus on whatever is an integration, okay, and try to compare with the formula of C1. If you look at the formula of C1, what you have here is you have x squared. And we're almost close to this formula. The next thing that you require to have is you need to have something square in here. So you need to have a squared, right? What we have here is not squared. We have 9 over 16. And try to manipulate this 9 over 16 into something square. Okay, the 9 over 16, what you can think of is it is actually equal to 3 over 4. And square. And you square it back. Okay, so you will still get back 9 over 16 and 3 over 4. You square it, you'll get back 9 over 16. Okay, when you do that, the next thing that you have to check is what is your A value here? Your A value, that is 3 over 4. Okay, when you are exactly, you are having some integration which is in the exact form of this, then you can apply the formula directly. Okay, so the answer it will be, okay, the 1 over 8 is still there, and let's just apply the formula of the integration of this, okay, by using the C1. Okay, so the C1 says that, okay, as a result of integration, you will have 1 over the A. Now what is your A? Your A is 3 over 4. You will have 3 over 4 here. And we have the tangent inverse, and we have x over the a. The a is still 3 over 4. So we have 3 over 4. Alright, okay. And lastly, don't forget to put your plus c. Alright, okay, let's simplify. So you will have 1 over 8, and this is 4 over 3. Okay, and this is 4x over 3 plus c. Okay, of course, you still have to simplify this. Okay, so using your calculator, and this is actually give you 1 over 6. So this is the answer for the question A. Okay, let's just look at the example of the 7b. Okay, so in here we have the same case where we have the constant at the top. Alright, whenever you have the constant at the top, what you have to think of is try to use the formula of C1. Okay, but let's just compare whatever we have at the bottom with the formula of the C1. The formula of C1, that is x squared plus a squared, but what we have here is not exactly the form, not exactly in the form of C1. So it means that you have to manipulate it just that it is in the form of C1. Okay. How to manipulate it? Okay, so you need the technique called completing the square in here. Alright, okay, let's just look at the x squared minus x plus 2. Okay, we just focus on whatever down here. And we try to manipulate just that it's look exactly at this. Okay, so in completing the square, what you have to do is, okay, just copy back the x squared and x. Okay, remember, okay, now you have to plus with a number or a coefficient from the x. Okay, the coefficient, okay, this is minus x. The coefficient of minus x is minus 1. So just plus with minus 1. Okay, and remember it is always have to divide it by 2 and close the bracket and make sure you add power of 2 here. Okay, once you have add an item in here, and in order to make sure that you do not change the fractions, you do not change the polynomial, so you need to minus back. So we copy back exactly the same item that we have added just now. Alright, okay, don't forget the plus. Okay, so then, okay, the first 3 items, you can simplify it into this. Okay, so just focus on whatever from the first item in here. So this will give you x. Okay, and then take the item from the tip. So you have minus 1 over 2, just right here. So you have minus 1 over 2. And write it in terms of square. Okay, the bracket, and this means that this actually represent whatever at the top. Okay, so from 3 items you can simplify it to 2 items, but it is in terms of a square. Alright, okay, whatever at the back, you can simplify by using your calculator. Minus of this plus with 2 will give you 7 over 4. So that is what we get, okay, from using the technique of completing the square. Okay, now substitute whatever that you did just now. Okay, the completing the square. Okay, take the last line. Okay, just put it here. Now we have this. Okay, so of course the number 2 you can take it out. Okay, and we have the form. of this. Okay, try to look at this C1 again. It's supposed to be x squared, but what we have here is x minus 102. So means that you have to manipulate this one more time. Okay, just that it is in the form of this. Okay, how to manipulate it is not difficult. What you have to do is try to think of this one as u, sub this one as u. Substitute u as x minus 102. Okay, so when you sub the u as x minus 102, so you need to find the dx. Okay, so let's just differentiate here. So we differentiate here, so we have du, this one is dx. Alright, okay, let's sub again whatever that we let just now. Okay, this is the u, and we have the square plus 7 over 4, and you have the dx. The dx is actually du. Okay, now again, let's just try to compare with our formula of C1. Now it is very close to this now. So we have u squared here. Next is supposed to be a number squared. But what we have here is 7 over 4. So again, you have to do manipulation in here. Okay, so think of how to make this one to become something in square. Okay, so let me rewrite. So we have 2 u. Okay, of course for the 7 we do not have the perfect number, but you can write it in terms of 7 squared. Okay, how about 4? 4 you will have 2 square, right? So we just have to write over 2 to put them in a bracket, and you put a square for a bracket. Okay, if you square it back, so the square root and square will cancel, so we have 7, and this is 2 square, you have 4. Okay, so that is how we did it. Alright, so now again, let's just look at the formula in C1. Now, yes, we are in the form that we can use the formula that is the x squared. Now we have u squared, okay, and we have the a is 7 over 2. Alright, okay, so it says that when you are in that form, you can use directly whatever we have in here. Okay, so let's just integrate. Okay, so means that we will have 1 over a. The a is 7 over 2. Okay, and we have the tangent inverse, and we have the x over, okay, the a that is that's how we say it is 7 over 2. Okay, it's not x anymore, but because we are integrate with respect to u. Okay, so the formula is dx. Okay, but our case is du, so this is supposed to be in terms of u. So u. So you have to flexible. You have to be flexible when you use a formula. Okay, and plus c. Alright, okay. So simplify it again. So we will have this will be 2 over 7. This is tangent inverse. Okay, this is 2u over 7 plus c. And don't stop here because our original question does not has the u. Okay, doesn't have the u, but what we have here is the x. So you have to change the u back. Okay, where does this u come from? This u is actually come from here. So sub it back. Okay, so of course this one you can multiply. So you multiply, you will have 4 over 7 tangent inverse, and we have 2. Okay, the u here is that is x minus 1 over 2. Okay, and over 7 plus c. Again, whatever in here inside the tangent inverse, we still can multiply. So let's just multiply. So you multiply, we have 2x, and this is minus 1, and it's always 7. So done. So this is the answer for the question. Alright, okay, let's just look at the question C. Okay, let me push it up a bit. Alright, let's just look at the question C. Okay, we have the integrations of 3x minus 2 and 16x squared plus 9x. Okay, now what you have here is you have something different. That is, you have a linear on the top. You have a linear on the top. Okay, let me drag down a bit. I need the formula that we used just now. Alright. I need this. Alright, okay. So again, this two formula again. Okay, but what we have here is now we no longer have constant. We no longer have constant at the top, but we have a linear equations on the top. Right, what you have to do is you have to split these two into two different integrations. So just let the 3x become one integration. And you have the minus 2 become another integrations. Alright, okay, and then okay, because you can take out the 3, you can take out the 3. Okay, let's just take out the 3. You can take out the 2. Alright, okay, so when you have two separate things, oh, this is x, so this is x. Alright, okay, so now you have two separate, you have two separate integrations. Wait, for this one is back to our case of constant. Okay, where you can use the formula of C1. But this one is in the form of x, or this is that linear. Okay, so this you can use the formula of the A7. But how to use the formula of A7? So you need to manipulate a bit, just that you can have the f prime over f. Okay, so now let's look at this one. If this one, okay, let's focus on whatever at the left. Okay, so if we think of, okay, this one is your function f. And we try to look at the formula of the A7 now. This is your function f. Okay, if your function f is 16x squared plus 9, what is your f prime? Your f prime will be 32x, right? Okay, so try to manipulate this such that you have 32x. Okay, so if you look at here at the top, you want to have f prime at the top, so we need another value that is 32, right? Okay, so you do add a 32 such that you have an f prime on the top. Okay, just rewrite everything back. So you need the 32 here. We already have the x, but you just need the 32. So just add the 32 here. But we don't want to change the integration. So when you add the 32, remember you have to divide back with 32. So divide back with 32. Once you cancel back, you get back the original integration. We does not change. We do not change anything. All right. Okay. How about for the second part? The second part is the thing that we have did just now, where you have to factor out the 16. Okay, just that you can use the formula of C1. Alright, so we have to factor out the 16. So let's just factor out the 16. So you remaining of x squared plus 9 over 16, which is the exact things that we did just now, that is in your example 7a. Alright,